Hello guys, welcome back. In this video, let us learn one more service in AWS, that is Amazon Redshift. Till now, we have learned many databases like Amazon Redshift, Amazon Neptune we have learned, Amazon DynamoDB we have learned, and Amazon RDS we have learned. So now let us learn with Redshift. So now the question is, why do I need to know about this? Is there any need? Yes. If you want to store and analyze large data, if you want to store and analyze data warehouse, then you need to use this Redshift. For relational database, if you want to store large amount of data, then you need to use this. Let's see the comparison between them so that it will be very understanding to you. You can see here. Yeah. So if you want to process a relational database with a small storage, then this RDS is sufficient to you. Whereas in this RDS, you can able to store and manage up to 64 TB, or else at least based on the engine that you choose, you have the limits. For Aurora, you can able to store up to 64 TB. For SQL engine, you can able to store up to 16 TB. For other engines, you can able to store up to 32 TB. So when do this RDS is useful? If you want to store general purpose relational database, if you want to store and analyze in general purpose relational database, then use this RDS. So let's say this is all about relational database. So let's say I want to store more than terabytes. I want to store petabytes of data for relational database. Then is there any service available for me? Yes. That service name is Redshift. What is that? Redshift. So when do I use this Redshift? If you want to store and process petabytes of data, we call it as big data, nothing but their data warehouse. If you want to process big data, then choose this Redshift. So for this stores in the form of column format. Don't worry, I'll explain you about column format. Actually, RDS stores your data in row-based format. So that's why it can able to process only lesser storage databases. Whereas this RDS, this Redshift will stores your data in column format. So that's why this Redshift can able to process your data very fastly. Don't worry, I'll explain you each and every term in next videos. In this Redshift, you can able to store up to petabytes of data. Even in this Redshift, you can able to process your data parallelly. That means you can able to execute your data parallelly, which means parallel processing also available in this Redshift. In this Redshift, you can able to process your data parallelly as well. This Redshift stores your data in the form of column storage, and you can able to analyze, you can able to store your data and analyze your data by using queries as well in the Redshift. So coming to DynamoDB, when do you use this? You can use it for non-relational database. If you want to store non-relational database with limitless storage, that is unlimited storage, then you can choose this DynamoDB. If you have a need to store graph related data, then choose this Neptune. So now let's concentrate more on this Redshift. When do I choose this Redshift? If you want to store a large database, if you want to store a large relational database, then choose this Redshift. Instead of RDS, choose this Redshift. When you have a large database, then choose this. It is good fit for analytical processing and large scale data warehouses and complex queries. You can remember like applications with variable workloads. Then choose this Redshift. This Redshift automatically scale, and this is useful for analytical processing, analytical applications. For complex queries, this Redshift is very suitable compared to RDS. RDS takes very large time to process complex queries, whereas this Redshift will process these queries for less duration. For large data, that is for petabytes of data, this Redshift will process you in less amount of time, whereas compared to RDS. Even the processing happens in Redshift in parallel mode. The only difference between RDS and the main difference based on storage is RDS stores in the form of row based, whereas this Redshift stores in the form of column based. So let's see about them in detail. You can see this comparison between databases is very understanding. You can see under RDS what storage type it is. It is a row based storage type, whereas DynamoDB is a NoSQL storage type, whereas Neptune uses graph-based storage type and Redshift uses column-based storage type. When do you use this? You use it for data warehouse. So in this Redshift, how much amount of storage can I able to store? Up to 2 petabytes. Whereas in RDS, how much amount of storage limit I have? I have only up to 64 TB. Up to 64 TB only I can able to store. So when do I use this RDS? For common databases with minimal administration, that means for very less storage databases, then you prefer this RDS. Coming to Redshift, when do you choose this? You choose this for analytics, complex queries, and massive parallel processing and column storage. This Redshift is useful for us. Coming to DynamoDB, we choose it for applications where they're having variable workloads and they are used for OLAP, that is online transaction processing. Whereas this Redshift is used for Redshift or RDS is used for what? OLAP, online analytical processing. Relational databases are used for online analytical processing application, whereas non-relational databases are used for online transaction processing applications. So based on your need, you need to choose. So let's see more about this Redshift now. By using this Amazon Redshift, we can able to store and process large scale data like data warehouse. Sir, you told we can able to store and process large data, right? Yes. So on which database engine is this Redshift is storing and processing this large scale data? So before that, let us write the limit of storage size. The limit of storage size. The limit for storage size on Redshift. On Redshift. So this may ask you in certifications as well. The limit for your storage size will be up to 2 petabytes. Up to petabytes. You can remember like up to petabytes you can able to store your data. So this is a relational database. This is a relational database. So now the question is, on which database engine we are storing and processing our data? Actually, on which database engine we are storing and processing our data in Redshift. So in which database engine we should store and process our database is on variant of Postgres SQL. Variant of Postgres SQL. So only this Postgres SQL variant is available for you as underlying database engine for this Redshift. So for this, we can able to, this is similar to SQL. You can able to implement most of the SQL queries under this variant Postgres SQL. So how can we process? You told we store our data in Redshift. Now, how to process? By using queries only, right? Yes. By using queries, we can able to process our large data. So for querying, which database we are using? Variant of Postgres SQL. Variant of Postgres SQL. So in certification, they may ask you which type of database queries do you execute on the Redshift storage database. Then you need to only tick the variant of Postgres SQL, because they may confuse you by providing only SQL option and Postgres SQL option and variant of Postgres SQL option. Then you choose only variant of Postgres SQL option. So here we process queries on Redshift data by using variant of Postgres SQL. Okay, we can able to analyze and query the data stored in Amazon Redshift by using variant of Postgres SQL commands. Okay, Redshift is why it is designed. It is specially designed and optimized for analytical workloads. For which type of workloads? Analytical workloads. On which type of data? Big data. So actually, this Redshift is specially designed and optimized for analytical workloads on large data sets. That is nothing but big data. So Redshift is heavily modified for you to manage big data workloads efficiently. So it is optimally designed, that is specially designed and optimized for OLAP workloads, that is analytical processing workloads on large data sets. If you're having small data sets, then what is the suitable service for you? RDS. Since you are having large data sets for OLAP workloads, analytical processing workloads, that's why you are choosing this Redshift. For OLAP workloads, we choose relational databases. For OLTP, that is online transaction processing workloads, you use DynamoDB database. That is what? That is non-relational database. I told you previously how this Redshift stores data in the form of column manner. In column manner, right? Yes. So it's actually a column storage. Redshift is a column storage. Why it is storing in the form of column storage? So to improve query performance, Redshift uses column storage format. To improve query performance, Redshift uses column storage format. So how Redshift stores your data? It stores your data in the form of column storage, right? Yeah. So let's take an example to analyze this column storage, how this column storage works in Amazon Redshift. Let's say you have a table in Redshift named sales. So this is the sales table, you can assume like that. That contains data about sales transactions with row storage. If you use the row based storage, the data for each row will be stored together in a disk. So if you choose RDS, RDS is which type of storage? It's a row based storage. There, how your data will be stored is your row, that is from here till here. So this is one row, right? Yeah. So like this row will be stored like this row will be stored as one disk in row based storage. So here you can see in row based storage, one row will be stored as one disk. So this is how your data is stored under RDS. So since we are discussing about Redshift, how Redshift will store your data? In the form of columnar storage. In the form of columnar storage. How? So it stores one column as one disk. How it stores? One column as one disk under column storage. This organization even enables Redshift to efficiently perform analytical queries that involves aggressive filtering and projection. So let's see one of the query among them so that it will be easy for us, right? For example, when you run a query to calculate total sales, total amount of sales, if you want, then you run a query for that. Then Redshift, under this Redshift, what it will do is it just reads and process two columns, that is first column and last column. It takes it as a key. So based on it accepts it as a sort key. So based on this, it will accept only the last column. Whereas if you see under row based, that is row based distribution, it will take this whole row and store somewhere and process for this total amount. It will take second row and store somewhere and process this total amount. And it will take third row and store somewhere and process some data for this. And finally, whatever the data it was taken for total amount, it needs to add all the things. So for this, it takes some time. Since it is a less size data, it may not vary a large amount of time. So let's say if you are having 100 records or 1000 records or even millions of records, like this, you are having a millions of rows in your table, then is it fast? Is it fast to get the response in row based storage? No. Whereas coming to this column based storage, it is fast because it just identifies the particular columns. It just checks the first columns as well as the what are the required column. So based on the key, it will identify what are the column you want, and only that column will be identified for whatever the your requirement. Since we require total amount, it will check all the data and simply find the sum and provide us the sum. So in this way, it provides you query response very efficiently in Redshift compared to RDS or other row based databases. You can say RDS is the only there. So currently RDS is the only there. In future, may they introduce based on client's requirement and need. Under Redshift, product ID, let's take it as sort key, and it identifies the total amount. Based on the product ID, it will identify the total amount. Like that, it just process only two columns. So in this way, very simply, you can able to get the result for this. So in this way, you got a resulting in fast response, fast query performance in Redshift. So compared to row-based storage, column-based storage provides you quick and fast response. Because in column-based storage, rather than reading whole data and storing whole data and processing whole data, what it will do, it just process the required column and provides you the response. So since that's why it resulting in fast response, fast query performance and fast response. So I hope you understood this, how Redshift provides you a quick, fast query response. This is this is not the only reason for fast performance in Redshift. There is one more reason available, that is MPP. What is that, sir? Massive parallel processing. I told you, right? While discussing about comparison, this Redshift also provides us parallel processing. So before seeing how data is processed, let's see how the Redshift architecture was. So whenever we create a Redshift, this Redshift first creates a Redshift cluster. So what does this Redshift cluster contain, sir? This contains two types of nodes. First one is leader type nodes and second one is compute nodes. First one is leader node, second one is compute node. This cluster contain either one leader node or multiple leader nodes, and it also contain compute nodes. It also contain compute nodes. Let's say this is my compute node, and the above one is the leader node and below one is the compute node. So like this, a cluster may contain multiple leader nodes and multiple cluster nodes. Whereas inside this cluster, this inside inside this cluster, we're having compute node, right? So here where under the compute node, our data is stored and processed. Actually, our data is stored in these compute nodes and processed in these compute nodes only. Whereas this leader node, what it will do is, it will manage all our queries. It will manage all our queries execution by using these compute nodes. So this is a leader where it can implement all these compute nodes by sharing, by partitioning the query and sharing equally. So now let's see about these. This compute node is again partitioned into slices. Based on node type and node size, this compute node is again partitioned into slices. This each compute node contains either multiple slices. How this compute node is partitioned into multiple slices? Based on node type. What are the node type that you selected for your compute node, and what are the node size that you provided for your compute node? Based on that, this compute node is again classified into slices, again partitioned into slices. So what is a slicer? A slice is nothing but a portion of your cluster resource, where the slice contain some CPU, some memory, and some storage. It's nothing but you can assume this as a small compute unit. Nothing but we are dividing the compute node into partitioning into multiple slices based on our node type and node size of our compute node. So these slices will execute your actual data, actual query. Whenever we insert data into Redshift, what happens? Redshift actually distributes data based on some distribution style. So let's take one distribution style, that is a distribution key. This Redshift distributes your data based on the distribution key in column manner. So how your data is distributed? Your data is distributed in the form of column manner. So coming to this leader node, does it have any slices? The answer for that is no. This leader do not have any slices. Only this compute node is having slices based on node type and node size. So let's see how data is inserted. So whenever data is inserted to the cluster, then this cluster will distribute your data among these slices, based on some distribution key. In which format? In column format. So let's see what are the distribution styles we have. Common distribution styles we have. Data common distribution styles we have. Here you can see we have written 3 distribution styles. What are they? Event distribution, where in this the data is distributed evenly between slices. How data is distributed between slices? Evenly. So the next one is key distribution. In the key distribution, your data is distributed based on specific distribution key on your slices. Whereas the last one, that is all distribution. Here, a copy of entire table, a copy of entire table will resides inside each slice. That means each slice will maintain a copy of your whole table. So like this, the distribution styles are there. Whatever the distribution may be, but each slice can contain multiple column of your tables. So whatever the distribution may be, each slice contain multiple columns of your table. So whenever you store your data, whenever you store your table data in Redshift, what happens is under this Redshift will store under Redshift cluster. Under this Redshift cluster, we have compute nodes. Under these compute nodes, we are having slices. On those slices, actually your data will be stored. How your data will be stored? In the form of column format. Whereas each slice contain only one column. No, it contains multiple columns of your table. So like this, actually your data is stored in the Redshift cluster. So actually we started this for parallel processing, right? Yes. So let's see about how query is executed in parallel processing. Now let's see how your query is executed in massive parallel processing now. So how your query is executing? Here you can see there are leader nodes, right? Yes. These are the entry points. These are the starting entry points for all your queries under your Redshift cluster. So what these are? These are entry points. What these are? These leader nodes are entry points for all your queries. This leader node receives whatever the variant of PostgreSQL queries that are sent from clients. So who receives the queries? This leader node receives the queries of what are the SQL queries, that is variant of PostgreSQL queries that are sent from client. And this leader will pass them to where? To these compute nodes. So before that, what this leader node will do is this leader node will generate an execution plan. So what it will generate? This leader node will generate an execution plan. Where what does that execution plan include, sir? Which include which compute nodes need to process our query and which slices in compute nodes need to execute our query. So those all details will be present inside your execution plan. Who generates this execution plan? Your leader node. Let's say this leader node created this execution plan. Then what this leader node do, sir? Now this leader node then coordinates execution of, then this leader node coordinates with this compute node and provides the execution of queries equally across compute nodes. So what this leader node do? It coordinates with compute node and provides, what does it provides? Provides queries equally for execution. This leader nodes coordinates execution of query equally across your compute nodes. So how your compute nodes will execute these queries? Parallelly. So actually this leader nodes, in simple words I will say, this leader node distributes what are the breakdown tasks equally across compute nodes. So under the execution plan, this leader node actually break down the tasks. So what are the query given, that will be distributed or break down into tasks by using this leader node. Then based on the execution plan, this leader node will distribute what are the breakdown tasks available equally to compute nodes. You can remember like slices, equally to slices. Then what slices do? Slices in the compute nodes will process, slices in the compute node will process its portion of data. Each slice will process its portion of data. Each slice will be distributed with equal amount of work, and each slice will process its portion of data and generate results, right? Yes. So which type of results that these slices will generate? Intermediate results. Then whatever the generated intermediate results which were given back to compute node, and then these intermediate results again given back to the leader node. So now whatever the intermediate results which are received by the leader node, this leader node, what it will do is it will combine all the intermediate results to produce final query output. So it will combine all your intermediate results and produce your final query output. And then this leader node will send this to whatever the Redshift, then Redshift cluster, then back mechanism happens. That is this Redshift cluster will send back the response to the client. In this way, actually the processing happens. The query processing happens in this way. First, your client will send the query. Now the query will be taken by the Redshift cluster, and that query is given to leader node. What this leader node do? This leader node actually break down your task, break down that query into subtasks, so that it will create an execution plan. So each task need to be executed in particular node, in particular query, in particular slice. In particular slice, each query must be executed. So like that, it will prepare an execution plan. Now, after that, what this leader node do is, this leader node distributes whatever the breakdown task that it has equally among all the compute nodes, equally among compute nodes. Then what happens under the compute node? Under the compute node, what are the slices it has? Those slices will process their portion of data. Remember, each slice will do equal amount of work. Remember, each slice will do equal amount of work. Then these slices will process their portion of data, and what it will generate? They'll generate their intermediate results. They'll generate intermediate results. Now again, these intermediate results send back to whom? These intermediate results send back from compute nodes to leader node. Now, whatever the intermediate results received by the leader node, those all will be combined by using the leader node to produce the final query output. Now, this final query output will be sent back. So this is how actually your query execution happens. So here you can see, while providing execution to slices, how these slices will work? The slices will do equal amount of work, right? Yes. So at a time, this leader node will distribute breakdown tasks to what? Compute nodes. Since this leader node distributes at a time, all the breakdown tasks to nodes, multiple nodes, these compute nodes obviously execute those in parallelly on slices. Who execute those queries? Slices. So these slices, what are the slices that these compute nodes have? Those all executes your breakdown tasks parallelly. Here, your slices are executing what are the breakdown tasks that you are providing by the leader node parallelly. So that's why we call this process as massive parallel processing. What do we call this process? Massive parallel processing. So in this way, massive parallel processing happens on your Redshift cluster. Whatever the task given to leader node, this leader node will break the task into multiple tasks, then distributes equally among clusters. Then again, under these clusters, slices will do their portion of work. That's it. Parallelly, they do their portion of work. remember each slice will do equal amount of work. So they do parallelly and provide the results very fast compared to other types of process. This leader node will break down and distribute the task, whereas under the slices, it executes the task and it executes the task parallelly. How it executes the task? Parallelly and produce the intermediate result. This slices will execute all the tasks parallelly and produce intermediate results. Remember, each slice will do equal amount of work. Then finally, what are the results generated? Those will be intermediate results generated. Those will be given to leader node. Now, what this leader node will do is it will join all the intermediate results and produce a final query output. So this is how the parallel processing happens at slices inside your compute node. So I hope you understood this, how the architecture was and how the parallel processing was and how your data is stored. So I hope you understood when do you use this Amazon Redshift and up to how much storage we use this Amazon Redshift and in which format we'll store our data in Redshift, and what about the background structure, what are the Redshift cluster was we have seen, and what about the working. So whenever we send a data, how it will be stored and how it will be processed, I think you understood this. And what are the distribution styles of your data whenever you upload your table data to it, also you understood. So how the query is responded and how the massive parallel processing happens in this Redshift also you understood, I think. So I hope you understood this video. If you feel this video is contentful, then please like, share, subscribe and hit the bell icon to get the latest update. See you back in the next video with another good concept. Until then, bye bye guys. Thanks for watching again.